Summation formulas can actually help us find a total answer to a summation when we have our values k equal 1 to a top number to stop at. That's a fairly big number, and it would be too cumbersome to actually work this out by finding each individual term and then adding those all up. Now, certainly you can use this process when the number that you stop at the top is a smaller number as well, but a lot of times the time issue of which one would be a faster process kind of is not really a very big switch off between just working the problem out and using the formulas when the number's small. But when this number is a bigger span between the start and the end, it's much more beneficial to know some of the properties and the rules of summation to help you out. Now, I've listed here 3 different rules of the summations that will give us, or summation formulas that will give us a shortcut way of getting our totals when our terms are specifically these 3. And then also rules of summation that help us rewrite expressions that maybe allow us to use those formulas. And what I want to do is to show you an example of how to use these in the problem, summation k equal 1 to 49 of 3k plus 4. Okay, now I notice here that first the summation is on this expression that has 2 different terms. So it has a plus between it, so I have the term 3k and the term 4. The rule of summation listed here to the right says if I have a summation from a start number to an end number of an addition or a subtraction between 2 different terms, I can actually rewrite this as the summation of the first term and then the sign that your problem had and the summation of the second term when we're doing addition or subtraction. And basically this just works along with the commutative property of addition, which says we can just go ahead and rearrange our terms as long as we take the sign that's in front of them with it. And if we have a whole bunch of them that have the minus sign, we can factor out that -1 and break it up as those 2 summations. Now, how will we apply that here? Well, I make sure that I don't have any power on my parentheses. If I did, I would need to FOIL that out so that I would have it term by term. And then I'm going to apply that property. So I'll have the summation k equals 1 to 49 of 3k, and then plus the summation k equals 1 to 49 of 4. So we have those 2 different terms. Now, this summation k equal 1 to 49 of 3k is still not where I can make one of my substitutions to start with, but I do have a process that says if you have a summation of a number multiplied to an expression of your values, then you can go ahead and bring that factor of that number out front. So this is 3 times the summation k equals 1 to 49 of k plus the summation k equals 1 to 49 of 4. And I do need to make a correction right here with my subscripts. This should be a sub k in this place, and also here that should be a sub k. All right, let's get back to our problem at hand. Now look, it's 3 times a summation k equal 1 to 49 of k to the first. And when I look at these different summations, I find that this middle one has my index k running through and of k to the first. And it goes to the quick way of finding this total instead of listing them all out and adding them up by getting your total by just taking your top number, multiplying it to the value you have of your top number plus 1, and then dividing that whole answer by 2, and that will give you the same total as if you took each of these individual numbers and added them up. Gives you the same number, just much quicker. So I have here my 3 that's going to be multiplied 2. Now my k goes from 1 to 49, so that matches the start of 1 up to whatever my top out number is. 49's the top number, so I'm going to have 49 times 49 plus 1. Well, 49 plus 1 is 50. and that's all divided by 2. So I have a fraction there, so we'll probably want to write that 3 as a 3 over 1 as a fraction as well. And then plus, and then this next one is the summation k equal 1 to 49 of a number. There's no k here. And that goes along with this rule. The summation k equal 1 to your top out number n of just a number is the number times whatever your top out number would be. Because it's just that many of them added together, and we can get that total quicker by just multiplying your constant times how many of those you have added together. So here I'll have 4 times 49. Now when you go through the arithmetic of this, so you take 3 times 49 times 50, get that product and divide it by 2, and then add your 4 times your 49, you will see that you get a total of 3,871 as the value for that summation. And it saved you a ton of work. Instead of going through this process, saved you a lot of time, as opposed to just putting each of those numbers in and then working them out until you got to your value of plugging in your 49.